Hi everyone, welcome to the last video that is about exercise 5. And now step by step we will observe that how the dual basis construction fails in the infinite dimensional vector space. And as a first step we will see that CK is linear, so in the dual space. So that means we always have this equality for all polynomials and for all scalars. Please check it. But as a hint, I may recommend you to observe how this CK behaves in spatial cases like fix K as 0 and C0 will be defined as the constant term of this polynomial. And similarly observe for K equal to 1 and observe that whatever you put here, it's going to be evaluated the term, the coefficient A1. So, okay, after this observation, in the second statement, we will observe that we have a basis for K of x, and similarly how we observe in the first part, just please observe that for K equal to 0, C0x to the 0 is 1, just by the definition. C0x to the 1 is 0, because we have no constant term here. And it holds for each j when j runs through a n natural numbers. And similarly for k equal to 1, we can observe these equalities. And this observation allows us to define CKJ for each k and j as Kronecker delta kj. So this is the definition. Okay, so by using this fact, actually in part 3, you can also observe this set, that means CK is a free subset of the dual space. And actually, we are expecting it will be a possible candidate for a basis of the dual space, but we have a nice example, h of x, which is defined as the sum of the coefficients of the given polynomial. And we observe that h is in the dual space. Please observe that h is linear. But h cannot be spanned by this linearly independent subset. And to see the second statement, suppose not. Again, we are going to prove it by contradiction. Suppose that there exists some non-zero coefficients, alpha j's, such that H is the linear combination of CJs. So, but on the other, just again consider the definition of H. This equality in the dual space should be whole for all elements in the vector space K of x, and that means for all polynomials ai x to the I in K of x, we have this equality on the other hand. By the definition of H, we know that it is equal to the sum of the coefficients, and from part I we can observe that indeed it is equal to ai x to the I from 0 to n. So when we go this other way around, we obtain this equality and this actually equality is the if and only if statement of 0. Let me continue from this second page. This is the if and only if statement, which allows us to write CKs as a linear combination. So, but that means that by the assumption we know that these AJs are non-zero, we obtain linearly dependent subset of linearly independent subset of the dual space. So, yeah, this is a contradiction. So that shows us H cannot be spanned by this linearly independent subset. Moreover, this vector space properly lies in the dual space. And yeah, thank you very much for your attention, and please don't forget, wash your hands, take care, and all the best. Bye bye.